Thank you very much, and it's a pleasure to be here today. It's nice to get into a more green area than San Francisco, and I welcome your questions throughout the talk or at the end at any time. So this can be interactive if we wanted to. So please ask your questions. So I teach in both the Computer Science department and the Master's MS in Analytics program down there. It's a new program that just is in its third year, and if you have questions also afterwards about the analytics program, if you're a student interested in that area, I'd be happy to speak with you about that as well. So today, as George said, I'm going to talk about sentiment analysis, and specifically granular sentiment analysis, and we'll come to what that means in a few minutes. So, this is just the motivation, and everybody knows this, that the internet is full of user-generated content of all types, and it's growing all the time. New sites are emerging. These are the ones we know and love, Yelp and Amazon, but the amount of traffic is increasing all the time. The amount of opinions expressed on the internet is increasing all the time. So we have Twitter, we have TripAdvisor, we have all kinds of outlets for us as citizens to communicate with each other, to communicate with businesses, and on and on and on. So that's the context of today's talk. On the other hand, companies, nonprofits, the university wants to know how to improve their reputation, their products, their services, how to market things to us as consumers. And so they want to understand all that noise that's coming in from social media, blogs, and on and on. So how can we do that? Well, there's several challenges that we have to meet in order to do that. Of course, there's all these sources. There's Pinterest, now there's Snapchat. I don't know what your favorite ones are to communicate with your friends, but there's new sources all the time and huge volumes. I had some statistics on the growth of how many messages and how many users, but I'm not showing that because it's already out of date. It's a year and a half or so old, so the numbers won't, Twitter is, tripling or quadrupling every few months. And so 90%, 85% of the world's population is on social media. So the volumes are just immense. The other thing is, just accessing that data is a technical challenge. There's companies that help so there's data service companies, GNIP, DataSift, several others. I think GNIP was one that I was working with. I used to be in industry that got bought out by Twitter. So companies that help just manage and scrape all this data from these public sources. And I'm not going to talk about those first two challenges. The challenge I'm going to focus on today is to automatically scan that text and try to find information of interest, especially the opinions that are being expressed. And I'll tell you what I mean by the opinions and the sentiment that's expressed in that text. So, there's two kinds of language that we might try to understand. There's objective language, statements of fact, and there's subjective language, or statements of opinion. And so we need to be able to distinguish between those and try to find the relevant information in that subjective language. So just as an initial example, each of these are snippets from movie reviews on IMDb or Rotten Tomatoes or sources like that, where, maybe the first one is really obvious that it's part of a negative review, unbelievably disappointing. These are very emotionally charged words. It's not too hard to see that that's a negative review. How about the second one? Full of zany characters, richly applied satire, and some great plot twists. So if you looked at those words individually, like zany, is zany good or bad? is satire good or bad? Plot twists, you know, maybe that's good or bad. But overall, you can kind of tell that, as we as people can tell, that that's probably positive because of the word great, plot twists, and rich satire. So that's, that we could give that one a thumbs up and say that that's positive sentiment. Third one, the greatest screwball comedy ever filled. Again, a little bit of a mixed, if you just looked at the word screwball, it's kind of making fun of it, right? But in a good way. And again, the last one, maybe not so hard to identify that that's a negative review. So that's our goal, is to identify that the first and fourth reviews are negative and the second and third are positive. And this, overall, the techniques for doing this are pretty well understood at this point, and I'll talk about that in a minute. And part of it is the kinds of things I've been focusing on in these sentences, is looking at the individual words in those sentences and identifying from past experience whether those are positive or negative. So wonderful here is, you know, the word wonderful on its own is positive, but if it's prefixed with a negation word like not or wasn't or I never said it was wonderful, things like that, then you could flip the polarity of that word to being a negative sentence overall. And then there's other issues, such as who is it that's expressing the sentiment? Like in the second sentence, he knows it is wonderful. If I say this sentence, I'm not expressing a positive sentiment. I'm talking about the sentiment that somebody else expressed. So knowing who the author or expressor or agent that expressed that sentiment is useful as well, which I also won't talk too much about. But these are all the issues that people are looking at. And you can't just look at, so I talked about, you know, the negation word. So no one found it to be wonderful. The word no one is quite a distance from the word wonderful, but we would want to understand that as a negatively expressed sentiment. Whereas the next to last one, the negation is kind of way far away, and it's not really an explicit, it wasn't wonderful, it was that they were wrong about saying that it would be wonderful. So you can see that there's a lot of interesting issues here in understanding the polarity, the sentiment polarity of sentences. So, but as I said, many of these, for these review-wide sentiment classification tasks or sentence-level classification tasks into positive, negative, neutral sentiment, machine learning is the primary tool which we use as researchers. How many of you have studied machine learning in your classes? Oh, a few? Okay, great. So as you know, the idea here is that you create a data set. So you have these sentences, right? And we would label the first one with positive, the second one may be neutral or positive depending on what your goals are, negative, 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 right? So we'd have this labeled data set, and we would create some features from that to turn those labeled examples into what we call feature vectors that we in turn feed to a machine learning system. You've heard of maybe naive Bayes or decision trees or things, nearest neighbor, things like that, where we would feed those to a machine learning system or algorithm that can then identify the polarity for new sentences. And there's also background knowledge that also comes into play, and I'll talk more about the sentiment lexicons and give you an example in a minute, but that's the kind of thing I've been talking about, where we say, all right, we know that wonderful is typically positive and awful is typically negative. So that's our sentiment lexicon. And so the state-of-the-art accuracy for identifying the polarity, positive, negative, or neutral, of these kinds of data sets is around above 80%. It's creeping up every year. We get a little bit higher and higher, and you might say that's not great, but given that the difficulty of this task, it's much more difficult than just classifying text into buckets like it's a business text, or it's a sports text, or it's a new politics text. This is much more subtle language, as you could see. So 80% is actually pretty good. So I talked about negation. So this is one of the ways that we create features for negating words when we see these words such as not, or I did not like this movie. It's kind of weird. Now we create a word that has this prefix on it that negates it. So now we can learn, the machine learning system can see when I see not like, instead of identifying that as a positive word, it's now flipped to being negative. So these are the kinds of tricks that people have come up with to process text in order to feed it to a learning system that can handle sentiment. And of course, you can see there might be cases where that might not work as well, but overall, it does increase the accuracy quite a bit. And then I'm not going to go into detail about these, but there are several sentiment lexicons that have been created either by hand or semi-automatically. There's a whole area of research for learning sentiment lexicons so that you can figure out that in some contexts, this word estimable is an objective word, and in other contexts, it's maybe a subjective word that has slightly positive sentiment, or 0.75 out of a scale, on a scale of 1 to 0. So some of these are just positive and negative words. Some of them have additional annotations like, is the intensity of the sentiment being expressed strong or weak or in between? So this is just more for your information, and it's the kind of background knowledge that we incorporate into our machine learning systems as additional parts of the feature vector that we that we create from these sentences that we're trying to classify. Okay, so that we said 80%, that's pretty good, and I'm happy with that research. It's going along really well. This is the whole community that's doing this research. It's not just me, obviously. So, but what are some new challenges that I'm interested in taking on? Well, consider this tweet. As much as I absolutely adore BBC Question Time, Steve Coogan is making me hate this week's show so much. He's making me really angry, and then hashtag BBCQT. I don't watch this show, so I don't even know who Steve Coogan is. But this tweet doesn't just I can't just say this is positive or negative, right? Maybe the first phrase is positive and the rest is all negative, and we could break it up like that. But what I really want to know, if I'm BBC Question Time, I want to know what it was what are the particular things or people or what I'm going to call entities, what did I express sentiment about in this tweet? So in this tweet, I expressed, or whoever it was that did this, expressed positive sentiment towards the show as a whole, BBC Question Time, but negative sentiment towards Steve Coogan and towards this week's show in particular. And so BBC Question Time would want to know, hey, this week's show didn't go over so well with someone that was ordinarily a fan of the show. And so this is what we're moving towards. And this is where the granular sentiment analysis comes in. That's from the title of my talk, right? So we want to know at this more granular sub-sentence level, what are the sentiments being expressed? And this has wide-ranging implications, and now we can go from just reviews that are the overall restaurant, Firefly is 5 stars, to this more on the far right there you see the food is great, the service is a little less great, and the ambience is also a little less great. And then maybe you have things like how's the noise level that you can summarize from this review or from all of the reviews. And so you can get these features about the restaurant at this more granular level. when you're trying to identify the sentiment. Okay, so that's where we're going in the rest of the talk. So what do we need to do that? What do we need to do to identify this granular sentiment analysis, to perform this task? Well, we need to identify these entities or groups of entities towards which sentiment is being expressed. So again, we want to identify BBC Question Time as an entity, and I'm going to call those entities or groups of entities aspects in my talk. And the community uses different words for this. They might use entity, they might use topic, but I'm going to talk about them as aspects. They're aspects of the product or show or movie that we're reviewing, that's being reviewed in the tweet or being expressed, the sentiment is being expressed about. So we want to identify these entities within the text, and we want to identify the polarity, the sentiment polarity of those aspects, but in a particular context. So in this context, BBC Question Time is positive, as we've been saying, right? Steve Coogan in this week's show is negative. But in a different context, BBC Question Time might be neutral or might be negative. So we can't just say it's always that Steve Coogan is always negative, but we want to say in this particular tweet or sentence, which polarity was it? So this is this very specific granular level that we're aiming towards. Okay, so this, how do we extract these entities and identify them for sentiment identification? Well, this kind of research has been going on in other areas. So extracting entities per se from text is not new. So whenever you see your Gmail, right, and somebody sends you an email and says, hey, can we meet tomorrow at 2:15 in room 234? And Gmail now extracts that, right? So you can click on that and create a calendar entry right away. That's entity extraction. And that's, very, very accurate for those easier things like times, dates, locations. Google's very good at that, right? So this kind of extraction is not new, and so what's new here with the entities I'm trying to extract with sentiment? Well, it's a little more subtle. So sentiment can be expressed over very atypical phrases that you might not call traditional entities, that maybe don't fit into these buckets of locations or things like that. So this week's show we showed as negative sentiment. Is that really an entity? That's kind of weird to call this week's show an entity. And now these other examples are from a corpus I'm going to be talking about in my experimental results. From here on, the corpus is on restaurant reviews, so there's going to be a lot of food. So if you're looking forward to lunch, you will have your appetite whetted for the rest of the talk. So selection of meats and seafoods is something that is part of a restaurant review, right? I loved the selection of meat and seafoods, but that's not, I might want to, traditionally, I would extract meat as an entity and seafoods as an entity, but we want to know that whole thing had some sentiment expressed towards it. And there's another sentence in my corpus that talks about the fried mini buns with condensed milk and the assorted fruits on bean curd. This is a very long phrase that somebody is expressing sentiment about in one of the restaurant reviews in my corpus. So this is some of the challenge of granular sentiment identification or granular sentiment analysis. Another challenge is that when I'm extracting entities, I'm always extracting every time I see something like India or a location like that or a person, I'm always extracting it. But not all entities express sentiment, have sentiment expressed about them, might be the better way to say that. For example, in this sentence, even my Indian friend couldn't believe how good and tasty everything was. There's no polarity associated with my Indian friend. They're just the ones expressing the sentiment that things were good and tasty. And so maybe you don't want to identify that as something that has sentiment associated with it. So we're going to refer to these phrases as aspects. So we don't have to say the phrase that had sentiment associated with it. That's just, we're going to call that an aspect in the rest of the talk. Okay, so that's how it's different, but it turns out that borrowing techniques from information extraction works pretty well as an initial step towards solving this task, towards identifying those entities. And so we talked about supervised machine learning for identifying polarity. We're going to use a more advanced type of machine learning model called a conditional random field. And this is because we want to take advantage of the fact that this is a sequence of words, that we're trying to identify snippets from that sequence, but we want to use the whole context of the sentence and the relationships between these different words in order to understand which ones are entities and not. So what is this picture? This is our sentence, a sample sentence I'm going to use for some of the rest of the talk. The pizza is the best if you like thick crusted pizza. Well, we want to know that both pizza and thick crusted pizza are these aspects that we're interested in. And so everything that's part of an aspect has a special kind of tag to it. So this is the beginning of an aspect phrase, right? It's just the beginning, and that's the only thing in that phrase. So we just have be associated with this. Whereas over there in thick crusted pizza, we have this whole phrase, thick crusted pizza. The word thick begins the phrase. Crusted and pizza are in the phrase. And then we're done. And everything else in the word is outside the phrase. So that's what the O's are. So this is inside, outside, beginning, tagging scheme. And there's several tagging schemes that are used in the information extraction field. And I'm going to stick with this one for this talk. What's the machinery that we use? It's called a conditional random field. I'll talk a little bit about that in a minute. So we, again, label a set of sentences with these tags of IOB, which things are the aspect terms. And so people have to do this work of annotating these sentences with which phrases are aspects and which aren't. And that's a hard task. People don't always agree on that. We can come back to that if there's time at the end. But I'm not going to go into detail, and this talk in general doesn't have a whole lot of math. Here's your math for the whole talk. And a conditional random field, or CRF, is a discriminative probabilistic graphical model. That's quite a handful, quite a mouthful. But it's just saying that we want to consider, again, this whole sequence instead of just in our regular supervised learning, all we could do would be to classify one word at a time. And in this case, we want to jointly predict the tags for this whole sequence. And that's what these boldface Y's and X's are. The Y's are our IOB labels, and the X's are the words in this sentence. So given that we observed this sequence of words, what's the most likely, the highest probability sequence of tags? And I'm going to learn a model that can predict that. I'm going to model that conditional distribution of the sequence of tags given sequences of words using a technique called maximum likelihood. And I'm not going to go into any detail at all on how that's done, but this is a technique, CRF, that's been around for, I don't know, maybe 10 years now, a little bit more maybe, in terms of trying to model sequences of words. You might have heard of hidden Markov models. This is an undirected or discriminative version of hidden Markov models, whereas HMMs are generative probabilistic graphical models. So if you heard of HMMs, this is a relative of those. So that's extracting. That's how we figure out how we learn how to extract things like pizza or thick crusted pizza. And then we want to say, all right, pizza here is positive, and thick crusted pizza, maybe we could say that one's neutral, right? So once we extract those aspects, we want to classify them, each one that we found in that sentence, we want to classify them as positive, negative, or neutral. And so we use another off-the-shelf machine learning model called the support vector machine, which you may have run into if you took your machine learning class or artificial intelligence class. So support vector machines are kind of state-of-the-art classifiers that handle this task really well. And we can also incorporate features now. Now we're just, for each thing, each aspect, we just want to classify that as positive, negative, or neutral. And we give it some additional features. So for pizza, we might talk about the context around the word feature. So I'll show an example of the features in just a minute. So backing up to, so now we've got our two models, and backing up to how do we represent them to our machine learning system. And these are all the features I've been playing with in my research that I'll show you the results of in a few minutes, where we want to, for our, so we've got our aspect extraction task and we've got our polarity classification task. And so for the aspect extraction task, we want to use features about the token or word itself. That token is just another word for word that we use in NLP a lot, natural language processing, the word token for an individual instance of a word. And sometimes we do some processing on that. We want to know the part of speech tag. So is it a noun, verb, determiner, etc.? We use that as another feature. We also use our sentiment dictionaries that I talked about earlier. For each word, is this from our dictionary? Do we know its polarity? Does it have a sentiment attached to it in general? Just because it does in general doesn't mean it does in this particular sentence, but we use that as further evidence to help us with our aspect extraction. And so that's from the context around the current token, and I'll show an example in a minute. We get these features, and then so each the conditional random field is looking at each token and creating features about it in addition to features about the context. So features about the token that we use are things like this, where we look at capitalization, we look at the length of the word. We found that that was a useful feature. We looked at punctuation. Is it a function word? So the word the, and, not, etc. are function words. WordNet is this lexical database that has this hierarchy of how words are related. So the word car is a more general concept than the word motorbike or race car or hot rod. So we use this hierarchy, this semantic hierarchy that's provided by WordNet, and we use features from that. So we're using a lot of background knowledge. We're building on the shoulders of other AI researchers to include that as features in our machine learning system. And then we use this other interesting feature about whether this particular token appeared as part of an aspect phrase in our training set. So you might think that if a word frequently appeared as part of an aspect term, like Indian or pizza, that it's often going to have sentiment expressed towards it and be part of an aspect term. So we use that as another feature. So I'll show an example here. So here's our pizza sentence. And if we look at the word thin, what are the features that we create for that? I always like to show lots of examples. So hopefully this will help solidify what I've just been talking about. So the word thin for each word we have features for the context. So here we have the prior token and the next token, and those are features about the context. So the prior token was the word like. It's some crazy kind of verb, part of speech tag. It's in our sentiment dictionary, so it has positive polarity associated with it, right? The word like is positive. And then we have this other feature that is it a subjective word or objective word? Now you might think, well, once it's positive, I know it's subjective, but I want that as an additional feature because the fact that it's positive versus negative might not be as useful a feature as just whether it's subjective. And this is interesting. This is what we do in machine learning a lot. We throw a lot of features at our machine learning system. We throw all the features we can think of. into our NLP systems that are trying to learn, and we see which ones then we hope the classifier can find the patterns in this data. And there's very good techniques that can do that with our machine learning system that can handle these huge numbers of features that we throw at the system. Support vector machines is one of them that does pretty well with that. So we have the word, the tag, the positive or negative, and then we have our subjectivity classification. And then for the word thin, it's an adjective, so that's what the JJ is. It's neutral, it's objective. And then the next token, crusted, is another kind of verb. I'm not going into all the different kinds of verbs that are part of speech tags can be. Neutral, objective. And then we have all these other features we throw at it about the word thin, like it's not capitalized, it's not of length 3 or 4. Oh, it's not of length 3, but it is of length 4, so that's a little typo. Right? No punctuation, it's not a function word. And then we get the syn sets of the word thin. And thin, believe it or not, can function as a verb. So like I thinned the sauce, right? That's a verb, or an adjective or an adverb. So we throw all these, again, we're throwing syn sets that might be noisy at the machine learning system. And it turns out that syn sets actually help improve our accuracy. I don't think I have all the statistics with me of experiments we've run that try different combinations of these features and show the different accuracy, but I have an earlier paper I can send to you if you're of interest. That's, one of the things is just throwing all these features help or hurt the machine learning system. Okay. So these are our features for extracting information, and then we have features for, once we've extracted the information, which polarity are we looking at here? So again, our machine learning system gets some features. We look at a more limited set of features for polarity classification. We found that worked pretty well, but we're experimenting with more features all the time, different kinds of features. Bringing WordNet in here as well definitely could be useful, something that we want to do. But what we do for polarity classification is now we're identifying, again, the sentiment for pizza or thin crusted pizza or Steve Coogan or whatever it is that we've already extracted from our larger sentence, and we're saying in this context, is it positive, negative, or neutral? And so we want to use features from the context of this whole phrase that we're classifying, BBC or Steve Coogan or the sticky buns phrase from earlier. So we look at features from the word before the whole phrase, we look at features from the word after the whole phrase, and then we just look at the head word of the phrase. So that's typically the most important noun of the phrase. Like thin crusted pizza would be pizza. Steve Coogan would be Coogan probably. What's some examples we had before? Fried mini buns with the condensed milk and the assorted fruits on bean curd. That would be the buns, would be the head of that whole complicated phrase. So it's not always the last word in the phrase, but that's one heuristic you could use. So we want to look at buns as the most important word in that whole phrase. Okay, so we're looking at our features for the phrase, and again we're using the part of speech tag, we're using our sentiment dictionary, and now we can actually use, we're doing this in sequence. So first we're extracting things, and then we're identifying the polarity. So we can use the tag from that IOB tagging scheme I showed you as another feature. So that's kind of weird, right? But is the prior phrase part of an aspect phrase, etc.? Might be, again, useful information. We're throwing all these features at the system and hoping that they're useful, that the machine learning system can find patterns in this data. And then we also use many of these phrases, like our Steve Coogan example or thin crusted pizza, they have more than one phrase in a single sentence. And so the classifier can march down the sentence for every aspect phrase and say, is this one positive, negative, or neutral? Is this one positive, negative, or neutral? Sorry, I have my phone doing something. Okay, I usually teach at this time, so it was telling me to go teach. So I'm giving a midterm in my absence. It's great. So that's the first time you guys laughed my whole talk. That's funny. So we look at the guess sentiment from the most recent phrase, if any. Okay, so let's recap. Where are we now? We're trying to learn to extract the aspects via this sequence learning conditional random field I talked about. We're learning to label these aspects with polarity via standard classification. Is there a problem here? What? It's not perfect? Excuse me?
It's not perfect yet?
It's not perfect yet, for sure, right? So our aspects that we're extracting might be wrong, and our sentiment polarity might be able to, it needs to know the aspect terms before it's identifying the polarity. And so can we use some kind of feedback between this process, these two related tasks of extracting aspects and identifying sentiment? And so we're going to change our paradigm a little bit so that we can try to see how much this can help our system. And so what we do, there's two approaches here. So the pipeline is kind of what we've been saying. We train our two models, but then when we are identifying polarity for a new sentence, we're not going to know what the right aspects are. We're just going to have our classifier guess at what they are, and those are the only ones that the polarity classifier has a chance to identify as positive, negative, or neutral. But there's another way that we could look at it. We could try to both learn aspects and their sentiment polarity simultaneously. And so now I'm going to change the tags on this crazy IOB scheme that I talked about so that I append at the end the polarity of that phrase. So for pizza, this is a positive phrase. So I have this pos. It's the beginning of an aspect phrase, but it's also that whole phrase is positive. And here, this whole phrase is neutral, right? The beginning of a phrase as neutral, the inside the phrase is neutral, etc. And of course, a whole phrase is always going to have the same polarity. Maybe in future work, you could flip the polarity in the middle of the sequence, maybe. That's something I hadn't considered, but that's an idea. So now we have our IOB tags that have these polarity labels on them. But the O tags just stay the same because they don't have any sentiment attached to them. And we might also have conflicted polarity, which I haven't talked too much about. But the data set that I'm going to go through real quick, I know we're getting close to the end of time, is, and it's time to take a nap too, I guess. So the data sets that I'm looking at are from a task that it was like everybody gets together and tries to throw their systems at this task. And it's restaurants and laptops are the two kinds of reviews that we're analyzing here. And here's an example where the word fajitas is conflicted polarity. So we have yet another category, positive, negative, neutral, or conflict. Because here they're both positive and negative. They're great to taste but not to see. And so we have about 3,800 sentences in these two domains that we're going to try to, now we want to know how well does all this stuff work. So we're going to evaluate our system. Here's a little bit more about the sentences. And the thing I want to point out is how many words are in a phrase, an aspect phrase on average. In laptops, they're a little bit longer than in restaurants. But it's interesting that the number of sentences with an aspect phrase is dramatically more with restaurants. So there's this interesting characteristic of the data set here. And this also tells you how many sentences in this data set are positive, negative, neutral, or conflict. You can see not very many are conflict. But the trade-off between positive and negative is different in the two data sets. And there's a high percentage of sentences that have more than one polarity. So in other words, sentences that have both positive and negative, or both positive and one of the other, two of these classes in them. So we can't just say the whole review is positive and be happy, because in 14% of the cases we're going to be wrong about that. Okay, so how did we do, and how do we evaluate this? We use a thing called precision recall and F measure. If you've, again, studied information retrieval or things like that, you've seen these metrics. So of all the, precision is out of all the things that I guessed, how many of them were correct? So how precise was I? And then of all the aspects that I could have gotten, how many of them did I get right? So I think of this as, you've heard the phrase, the whole truth and nothing but the truth. Recall is the whole truth, and precision is nothing but the truth. So that's how I think about them. So, and then we want to look at, an F measure it's called the harmonic mean. It's like an average of these two metrics. And then for polarity, we look at just raw accuracy. How many of those did we get right? So let's just look at our original models of not the pipeline or the collapsed, but we're doing extraction, and then with the correct aspect terms, how many of those did we get correct? So this looks okay. It's actually F metric of 78, the high 70s and high 60s for laptops. So laptop's harder. It's got more diversity in the vocabulary. It's got these longer aspect phrases that I think is making it a little bit more challenging. And then the sentiment accuracy isn't great. It's in the low 60s, and we've got some other results where it's a little higher. And this is on tenfold cross-validation over the data set. If you have questions about that, maybe we can talk during the question period if there's enough time left. So just kind of want to show you these results, but how well does collapsing the labels help? So before we saw an F1 of 78 and 67 when we're doing this in a pipeline, but when we collapse, the F1 metric goes down just a little bit. So that's a harder task because we've got more labels to predict. We've got IOBs with these suffixes on them. But our sentiment accuracy is much, much better. It's not hurting. It's barely lower than this. In this case, we had the correct aspects. I should have put these both on one slide. This, we had the correct aspects, and we're able to get the low 63 and 62. And here, even though we're jointly trying to identify both aspects and polarity, so we don't have the correct aspects, we still can get almost as high a sentiment polarity accuracy. So that's over all the sentences in there. You see that if we try to learn these in sequence, so in this case we're giving the sentiment classifier just the aspects that we got right, it's not doing very well at all. So that's the main results here, and I just want to wrap up. There's lots of related work. I know we're running close on time here that you can ask about. We want to look at semi-supervised learning because, as I said, labeling these sentences is quite challenging. So how can we reduce that annotation burden? So that's what I'm working on right now. We want to evaluate on other data sets. And I think it's a really interesting problem. There's a lot of research challenges, and we want to continue on looking at this. So thanks for your attention. I'll take your questions. Yeah.
What features do you feed into the collapsed support vector machine?
Great, good question. So the question was, what features do I feed into this collapsed model that I talked about? And I use the same features that I use for the other model, for the sequential model. Now, because we're trying to learn both sentiment and polarity at the same time, we can't cheat and tell it what the IOB tags are, because we're trying to learn them both at the same time. But yeah, it's essentially the same features as we had down here. Good question. Thank you.
On places like social media, it's really common that you'll find like a lot of sarcastic comments.
Sarcasm.
How well does that play a factor in?
Absolutely, and I haven't explicitly looked at sarcasm here, but it's a great, so the question was, what about sarcasm? And sarcasm is much, much more challenging, right? Global warming is great, right? We know that that's probably not positive sentiment, but so how would you identify that? And that's something I also would like to look at. Yes, in the back?
I was just thinking about how language, words in particular language change meaning over time. They take on different meanings.
Right.
So I was wondering, have you considered that?
Yeah, so the question was, words evolve over time and their meaning changes. So right, and it's not just that, it's that in different contexts the word can have very different meanings. So there's this field called word sense disambiguation that deals with that. So yeah, identifying language drift, and there's new words that occur all the time. So, you know, the word Google is now a verb, and so on. So yeah, so we have to either, that's where the semi-supervised learning idea comes in, is that instead of us always having to tell the computer, hey, here's this new thing happening, it identifies these trends on its own and says, hey, there's some anomaly going on. Now this word seems to not be fitting into the patterns that it fit into before. Great question. I think there was one, yeah.
Is this what Amazon uses to determine whether it's a positive or negative 3-star review, for example?
Yeah, I don't know what they use. That's a good question. So the question was, is this what Amazon uses? I'm sure they use similar techniques. So I'm sure they use label data. And you might see if you go to something like, I know a lot of people crowdsource, so the Amazon Turk, you know, people crowdsource these annotation tasks. So if you go on there, you might see somebody asking you to annotate some data with sentiment polarity. So now you'll know exactly how to do it.
Well, Dr. Thompson, I wanted to remind you that we computer science people are experts in pizza.
Yes, pizza.
And the difference between a thin crusted and a thick crusted is a big difference.
I agree, yes. Which do you prefer? Depends on the day for me. Well, thanks again. I enjoyed speaking with you today.